This video was made by Alan Becker and his team. Please consider giving a like to the original video before watching the reaction. And now, onto the video. Have a good day. Okay, I can already see that this is gonna become someone's wallpaper. An animated wallpaper of orange just falling through the universe. Okay, that I know. D equals distance. Oh, this is cool. They're gonna actually be showing little markers. Ooh. Vehicles. There will be a lot of terms which I will not be able to determine the correct nomenclature just because I was not taught in English. And yet, in addition to that, I was not the best physics student at college or at school. Okay, mass. And acceleration. Force equal mass times acceleration. Okay, that I know. Friction. I hated when we had to add friction to the calculus. Okay, so the ice is so slippery that he cannot actually have any friction to be able to move. Okay, so I guess the objective of this video is him trying to be a little bit higher. He will try to get to the little sphere to get out, right? That's an angle. Angular momentum. Oh, so his force throw is 50 kilograms. That is good to know. This is actually very cool to watch. And where does these objects keep coming from? Ow. I don't know why, but that tree right there is actually kind of reminding me a little bit of Soul. Have you guys ever watched that movie? Okay, now we're gonna start to get into some terms that even in Portuguese I was not good at. Potential energy becoming kinetic energy. Okay, that thing I know. I know what just happened here. I've seen a video of a physics professor actually teaching that if you drop a sphere for a certain angle, if it has like a line holding it down and allow it to swing, it will actually just go as high as the point it started for the initial movement with the potential and the kinetic energy. That when it returns, it will be on the same exact place. It will be on the same exact height. No more than that. So he let the ball go, and as soon as it came back, it was right about to touch his chin, but it didn't. It didn't. And I remember him saying that if I'm wrong, I will need probably to be hospitalized or something like that. So it was a very cool show of trust between a man and his knowledge. So I think that we'll have to get a little more kinetic energy then. There we go. And excess kinetic energy, which will be lost with time, since now the gravitational force will probably reduce his speed instead of adding to it. still amazes me how well Alan Becker and his team can actually just make so amazing 3D backgrounds to be interacted with. They seem like they are 2D, but they are 3D in the sense of the stick figures. Okay, that is very cool. And now since he got to space, his gravity no more depends on the planet. It actually depends on this rocket. Damn, I really wonder how many professionals or physicists they actually had to hire to be able to do this correctly. Okay, we got thrust. I remember seeing this hat on the thumbnail, and this is a question. Is this like, since he has a rocket and a cowboy hat, is this a reference to a very old and black and white American movie where the guy goes down with the nuke and he goes with his cowboy hat and he goes just having the time of his life? What's the name of that movie? Okay, so we changed angles. We're not watching the TD to the 2D from the perspective of the planet. We're watching the perspective while we're heading to the direction of the sphere, the white sphere. Velocity is increasing 1 meter per second. Okay. So this is the maximum speed. It's amazing the things that you can find in space. Oh, speed of light. Wavefront. This is the type of thing that I would be terrible. I would always lose some points in my exams when I had to actually do anything with light speed or the waves. And this music, amazing. Oh, I think I know what he's gonna do. Oh, he's gonna start using the planets to get more speed. Because since they are also rotating, I think he's actually you're gonna use the speed of the solar system to be able to go even faster. He's using the kinetic force of the planets to actually impulse him even further. Oh no, the mass of this planet is actually too big. I'm surprised that he's not being dragged down by it in a faster manner. Oh, orange. Oh, amazing. He actually just used a solar system for a ride. Incredible. Oh, I remember the name of this. I know it's a magnet, but I totally forgot the name of the things that magnets are used in physics for. Magnet field. Also, it's just a magnet field. We're just gonna go for magnetic force. I think that I didn't study that, but we just mentioned that in class. Really, how many things are in space? Are these giant magnets? I have no clue what it just did, but I think it just increased the magnetic force being expelled by the rocket. Or it actually made it a point of magnetism. And another question, is that B right there the speed of light? Does he need to get to the speed of light to be able to get there? Because it's at 80% of B. I don't remember what B means. Star system, asteroid field, nebula. There was also a comet. Oh, he just left. He just left the universe, or a galaxy. Quasar, spiral galaxy. I have no idea what is this. Now I'm completely lost. But damn, this is actually beautiful. I have heard of the Doppler effect, but I have no idea what this is. Is that a black hole? It is a black hole. I know that this is a black hole due to movies Singularity. I really don't know what is a singularity, but what is this? Is it the theory that any object... I think that my internet just went down for a second. I'm sorry, guys. Yep, I think that my internet just went down. But really quick, while the internet is down, let me just take this moment to be able to comment on the fact that I think that the theory of the black hole is that an object that goes into it can actually reappear anywhere in the universe or something like that, right? They don't know what is beyond a black hole, but it's theorized that black holes are like wormholes, isn't it? Or I'm going crazy. I'm going to try to fix my internet. Or oh, it actually came back. Perfect. My internet actually gave me enough time to comment on black holes. But really, thanks, internet. Let's keep going. And he's actually going. He's actually going for it. Good thing is a stick figure because it's very, very risky to go inside a black hole. We have no scientific capacity to be able to know what is beyond the black hole. Oh, the apple. It keeps coming back. Wait, since the apple is a singularity, so since he touched the singularity, now he became a singularity? Or does this allow him to be able to go through the black hole and go out in another one? Oh, he's actually growing up again. He's going through... I think I know what is happening here. I think that the theory says that a black hole, the way that you go through a black hole, you actually... You're basically dismembered, or you're reduced to the size of a cell, right? So that is what is happening with him. He's actually shrinking down to be able to go to something that is as tiny as a molecule to be able to pass and then go through the outside. Okay, I think I get it. Electron, a proton, quarks, antiquark, neutrinos. And there it goes, it's just shrinking and shrinking. World sheets. Is this the smallest known thing to man? And singularity, there is the other side. There's the other side. Einstein-Rosen bridge. Oh, so he's watching himself. This is getting way too weird. Also, they were the ones giving the things to him, so this is becoming a paradox. So that's why and where these things were coming from. And that's gonna become a ball, isn't it? Yeah. And at one point he's even gonna throw the hat to himself to close the circle, right? And it's gonna speed time a little bit. Also, he gave the apple to the thing to be able to grow it. So himself was helping him. For how long was he stuck there to be able to do all of this? Also, is this like the physics way to describe a god? I don't know, it feels like this is actually amazing, incredible. And there's the apple. And it keeps going back, that's why. And they both laugh at it. So they are the same person. And there he goes. And now it's up to him, because now he will close the circle. And the guy continues. This is his story. We just saw this happening, and now we go forward. The end. Please, come on. There's gotta be more. We're not even gonna see Alan by the end of it? Come on. And there is no... Oh, Jesus Christ. This was just too good. I did not expect the ending. You know, there might be more to physics than I actually gave credit for in middle school. And now I think I'm gonna go just go ahead and search for a physicist trying to dissect all of this, because this was amazing. And also the paradox at the end and the circle being completed, but the journey not being over yet. Amazing. I kind of wonder where they're gonna go next, because they had math, they had physics, and I really cannot imagine what's gonna be next. Guys, thanks so much for coming. I'm sorry if I was a little bit more quiet a few times during this video, but physics is not my forte, and it's something that I try to be a little bit more quiet, even though that can be very, very hard. You guys know me, I like to talk. Thanks so much for coming. I hope that you guys already gave a like to the original video to support Alan Becker and his team, and I really hope that everyone that worked on this project actually understood a little bit of physics, because damn, I most of the time couldn't understand anything in a physicist level, but geez, that was cool. So until the next time, video, reaction, YouTube short, or live stream, I hope that you guys are doing good. Okay? Bye! See ya!